our busy, crowded space neighborhood. Look up. Right now, above your head, there are thousands of objects zooming around planet Earth, faster than any bullet you've ever heard of. You can't see most of them, but they're there, circling the planet every single day. Today, you're going to find out exactly what's up there, and why some things fly close to Earth while others fly much, much farther away. What is low Earth orbit? Let's start with a number, 2,000 kilometers. That's about the distance from St. Louis to Denver and back, twice. If something is orbiting Earth below that height, we call it low Earth orbit, or LEO for short. Most objects in LEO actually fly much closer than that, somewhere between 200 kilometers up. Here's the wild part. At that height, things move fast. To stay in orbit and not fall back to Earth, a satellite in LEO has to travel about 27,000 kilometers per hour. That's so fast, it circles the entire planet in roughly 90 minutes. Picture this. Astronauts on the space station see a sunrise and a sunset every hour and a half, all day long. What's actually up there? So what exactly is flying around in this low, speedy zone? Let's count down some of the biggest residents. Number 1. The International Space Station, ISS. This is the biggest human-made object in low orbit, about the size of a football field. Astronauts from different countries live and work here, floating about 400 kilometers above you. Number 2. Tiangong Space Station, China's space station, built more recently, orbits at a similar height. Like the ISS, it's a home base where astronauts, called taikonauts in China, live for months at a time. Number 3. Starlink and other internet satellite swarms. You already know about these. Starlink isn't just one satellite. It's thousands of them, working together as a constellation to beam internet access down to the whole planet, even to places with no cell towers or cables. Number 4. The Hubble Space Telescope Hubble sits in low orbit too, above Earth's blurry atmosphere, which is exactly why it takes such sharp pictures of galaxies billions of light-years away. Number 5. Earth-watching satellites, weather satellites, mapping satellites, and satellites that track wildfires, farms, and storms all fly in LEO. Because they're close to the ground, their cameras can capture incredible detail. Number 6. Astronauts on spacewalks and their jetpacks. When astronauts leave the space station to work outside, they sometimes wear a rocket-powered backpack called the MMU, the Manned Maneuvering Unit, known in Chinese as Tree, Dongli Beibao, literally powered backpack. It has small thruster jets that let an astronaut fly freely through space without being tied to the ship by a cord. It was first used in 1984, and it turned astronauts for a little while into their own tiny human satellites. Number 7. Space junk. Not everything up there is useful. Old rocket parts, dead satellites, and even flecks of paint are zipping around too. Because everything moves so fast, even a tiny piece of junk can be dangerous, which is one reason space agencies track this debris very closely. Higher orbits. What's the difference? Now here's a question you might be asking. Is there a high orbit too? Yes, and it's a real term, though scientists usually break it into a few zones. Medium Earth orbit, MEO, sits from about 2,000 up to 36,000 kilometers. This is where GPS satellites live, the ones that help your parents' phone find directions. They fly higher and slower than Starlink satellites, and it only takes a couple dozen of them to cover the whole planet, instead of thousands. Geostationary orbit, GEO, sometimes just called high orbit, is way out at about 36,000 kilometers. Satellites here move at the exact same speed as Earth's rotation. So from the ground, they look like they're not moving at all. They just hover over the same spot forever. This is perfect for TV broadcast satellites and some weather satellites that need to stare at the same patch of Earth all day, every day. So what's the actual difference? Think of it like this. LEO is a crowded bike path, close to the ground, with thousands of riders zooming past every 90 minutes. GEO is like a slow-moving blimp, parked high above one city, that never moves at all. Low orbit equals closer, faster, cheaper to reach, needs many satellites to cover the whole Earth. But a signal from the ground gets there and back almost instantly. High orbit, geostationary, equals farther, slower, relative to us. Actually matching Earth's spin needs far fewer satellites, but the signal takes a little longer to travel that extra distance. So next time you look up at a clear night sky, remember, somewhere up there, astronauts are circling you 16 times a day, thousands of internet satellites are relaying messages between continents, and a jetpack once let a human float free above the whole Earth. Space isn't empty, it's busy. The sky is full of wonder.